This is a series that we're doing that is on Diagrid practical agents. So this is the second one in the series. We are diving into a number of these practical agents that are based on common use cases in the software development lifecycle. So last month, our AI team lead Casper did a webinar that was based on an AI agent making it production smart by using a dynamic web context before calling the LLM. And kind of the reason, just to give you some background, the reason we are starting with these scenarios is that we are working with a ton of users who want to kickstart their development with autonomous agents, and they might not know where to start. There are some use cases that a lot of people have in common, especially when you are building software. And so, whether you want to troubleshoot issues, writing something like release notes or raising PRs, SDLC lifecycle agents are a great place to get started from an autonomous agent perspective. And so that's what we're going to be doing today. We will be creating and running a durable SRE agent using the open source project, which is HolmesGPT, and our AI orchestration platform, Diagrid Catalyst. And this is, you can kind of think of an SRE agent, if you haven't used one before, as like your first line of defense, kind of that like first responder to any critical infrastructure issues that might be occurring, whether that's in your Kubernetes cluster or a VM or any sort of layer in the technology stack. And so the primary goal here is to have something to help you when, if you're an operator and an incident is occurring, being able to have a single point place you can go, to have recommendations, to troubleshoot, and really just providing insight into kind of what to do next before, eventually we would want the SRE agent to be able to implement these playbooks autonomously. But yeah, so that's what we're going to talk about today is this SRE agent, and we are going to be using this with we're going to be doing this with the open source HolmesGPT project, and which is a SRE agent. And then we're coupling that with the durability layer of Diagrid Catalyst, which essentially backs the HolmesGPT agent, providing a durable execution layer so that if it fails for any reason, if a pod goes down, if network issue happens, it will pick up from where it left off instead of having to rerun its full execution from the very beginning. So this not only ensures that the agent runs to completion every time, but it also saves costly like LLM calls or just like plain old resource usage from rerunning that process. Cool. So I'm going to get into it. I'm actually going to start with a kind of a common use case scenario. So I'm going to flip over now. Am I still sharing my screen? No, I think I am, right?
Yes, sorry, I can't see your screen right now, Alice.
Okay, no worries. I have to reshare then. Here we go. I guess I just have to do the full screen. So I'm going to start actually by sharing like a common, end-to-end scenario of a incident, right? So a lot of people, they would be getting their incidents right from Slack. They might have a alert manager or some sort of Grafana integration that would be telling them as a DevOps, as me, a DevOps SRE person, it would be coming right into Slack. They're getting an alert and they have to go and investigate what that alert is and like what's happening. So I think you can see my Slack screen here. I can see that I have a Kubernetes pod and it is in CrashLoopBackOff. It's telling me that this is in my production namespace. It's telling me what pod it is. It's the auth-service. So, authentication is a priority for me. That's probably something I want to look into. And it's going to give me the details of like what's going on in that pod. And then you can see at the very bottom here, it's saying, hey, why don't you take a closer look, investigate with the SRE agent, and like giving it actually this prompt. So I'm going to copy that guy. I'm going to click over into the browser, bring this over on the screen. And this is kind of my durable SRE agent. So this is where it's taking me, right? This is our user interface. It is just a plain old Chainlit UI. I'm going to copy that prompt that I want to look more into directly into the text box here. And again, this is like an example, a contrived example, of course, of like something that is failing within my cluster. We wanted to have a chat-like interface for integration, but there are a ton of different integration options with Holmes. It's not specific to Chainlit. This was just something we built. And you can see that this is kicking off a new, it's a new execution of this agent, right? So it's looking through a ton of these different skills that it has access to. So for example, some of these, it's looking at some Kubernetes skills in this case. I'm using Argo for my applications. So it's going to look at what applications are actually running within my cluster, and it's going to get a ton of these skills. I can see each one of these in terms of like the tool it's calling, as well as the output from the UI, which is really handy. And I can also, comes down here and it gets my full output and it tells me what's going on. So it's saying, hey, it found a skill named auth-service CrashLoopBackOff. It's going to run through this level of, or this sort of sequence of events, checking to see each of these different tools to see, okay, what's going on in this case. And what's the TLDR? Because, as an ops person, maybe you're busy. What's the thing it's telling me? This is in CrashLoopBackOff due to a low memory limit. The root cause has high confidence. It is 5 millicores, and it's going to tell me like where it got that evidence. So again, pulled a bunch of tools, gave me the output of each of those tools, summarized them all, and then put that into kind of a summary for my reading and my kind of next steps. And then it even gives me suggested actions on the bottom here in terms of increasing the memory limit and then, monitor that new rollout status. So this is just a bit of a flow of like what we currently expect. Again, like I'm going to jump into now a little bit of like what we actually saw there. So if I reshare this, I believe now you should be able to see my slides again. So I'm showing my full, yeah, okay.
Yes.
Cool, lovely. So what did we see? What did we see there? So we are using HolmesGPT, and this is an open source AI agent for investigating production incidents and finding the root cause. And essentially, again, it's a completely open source project. You can check it out. It's in just at HolmesGPT.dev. It was actually donated to the Cloud Native Computing Foundation as a sandbox project. And its main core, feature is that it investigates incidents across any infrastructure. Today, I'm using a Kubernetes cluster, but it could be a virtual machine, any sort of PaaS cloud services, databases, something else. And the main benefit as well is you can connect really any API as a data source. So when I ran through the list of steps, list of tools that it called, there was a number of, it was using Kubernetes, it was using Argo. There's a number of different tools that we are using in this sample, but you can really bring your own custom MCP server or use any of the list of built-in tools that Holmes has to offer. It has memory safe execution for each of its tool steps or tool calls. And then you can also run it 24/7 in what's called operator mode. So instead of, me having to go prompt the agent to tell it, hey, can you help me like debug this service? You could actually get it to run in the background consistently, both like providing potential fixes or actually, going ahead and fixing the issues that might be occurring. So yeah, check it out. It's an open source project, pretty cool. On the right here, it's just like another example of the CLI integration. Like I said, we just created a custom chainlet UI on ours, but this could be integrated into Slack, it can be integrated into Teams, really wherever your operator teams are living on a day-to-day basis. And then the other thing that we're integrating this with is, of course, our AI agent orchestration platform, which is called Diagrid Catalyst. It is, again, check it out on the top right. It is a durable execution wrapper. So it's essentially taking the Holmes GPT agent and then wrapping it within durable execution, meaning that like if any of these, it fails at any sort of point, it will actually continue from that point, from that checkpoint. It'll do like a replay and continue instead of having to restart from the very beginning. Catalyst also provides zero trust security and identity layer for all of your applications, for your agents, for your MCP servers. And you can have a really nice kind of topological view of how your applications connect with each other, how they connect with their MCP servers, and really from like a top-down governance perspective, see what those connections are happening, and then also allow you to give like access policies in between who can talk to who and who cannot. Lastly, there is a piece on Catalyst around agent cost reduction, just in terms of being able to do prompt caching and prompt response caching for sure. So we can kind of get into the demo of that in a little bit. But these two things together really are providing you this sort of production grade agentic system, because just alone, HolmesGPT, it's great, has a ton of great features here, absolutely. But really what we're adding is this layer in between the platform or your infrastructure and the agent itself, as this AI agent orchestration platform, providing these kind of production ready, systems with reliability, security, and governance. Cool. So why, I just want to take a step back, I guess, for a few minutes and talk a little bit about why reliability is critical for agentic systems. You can see, since we're on the topic of SDLC agents, imagine you have an agent that you want to run that's going to upgrade your entire Kubernetes cluster suite, right? So you are, again, on the operator team, and one of the things you want to do is upgrade all of your clusters. So you want to run, tell an agent, hey, I want to upgrade all my Kubernetes clusters. Cool. It's going to execute all in a workflow or an agent execution on a per cluster basis, right? So maybe you have 1,000 clusters. It'll run a workflow for each one of these. And it's going to go through that agent, turn execution cycle. It's going to do a plan, classify, and kind of run those or store those results. And this is kind of just a typical thing, like all autonomous agents, what they're doing is they're running through a turn of this cycle every single time they execute. Maybe they run, 5, 10 times, maybe they run 25. You can obviously specify that, but this is kind of just a basic cycle for any sort of these agents. Now imagine if they are failing, or imagine what happens when you have some sort of network latency, some, infrastructure failure, whether that's an availability zone, whether it's a mandatory security update from your cloud provider. All of these are super common scenarios across, whether you're running in the cloud, whether you're running on-prem, like failures are inevitable for sure. And so if a single step in this workflow that we're talking about, in this plan and classify and examine and store workflow fails, all the previous steps will have to be retried. You will have to start from the very beginning, essentially, for each one of those clusters. So imagine, you have your workflow, your cluster upgrade is on, number 999 out of 1,000. All the previous workflows will have to be retried. All of those previous upgrades will have to be rewritten, because there is no state checkpointing along the way, meaning that the agent doesn't know that 999 actually was successful and 998 is successful. It's going to have to rerun that entire thing from the very beginning. And not only is that super costly, right, but it takes a lot of time, it takes a lot of resources. And it's also extremely, extremely, extremely bad for business from that perspective. So this is kind of that layer that Catalyst is providing in this case. And if you think about it from a perspective of how this is running in action, I can think about it from a checkpointing perspective as well as a replay perspective. So, each of these steps, you can think of them as those steps in that cycle. My plan, execute, apply. And every single step it is running, it's going to be saving that checkpoint into an append-only log, an append-only state store. And it's going to go along, keep running its business execution or its business logic, and then saving it again, etc. So here we are on step 4. There's automatic failure detection here. So what's going to happen is it's going to crash, and then it's going to be like, okay, where is the most recent step that I have completed? It's going to look back into that append-only state store. It's going to replay from the very beginning. So step 1, 2, 3, and be like, all right, I don't have to go into those. I don't have to go into those business logic activities, and it's going to pick up from where it left off, and then pick up from step 4. So that is, again, saving a lot of time, saving a lot of effort from a resourcing perspective, and then also ensuring there's that kind of reliable underlayer within your systems. So this is really the core piece that makes this, like I said, this HolmesGPT agent production ready. And we can get a little bit now into the architecture of what we're doing as well. So as I said, we have this durable agent. It's a single agent. In this case, we have a number of custom MCP servers that we have integrated as well. So we have Prometheus that we're using. We have GitHub. We have Gigabyte, which is actually storing all of the custom skills. And then we also have Pulsar, and then really you can bring any of your own MCP servers here. It's a really like nice plug and play interface that Helms has. So you can have anything that's running in your cluster, any, like I said, custom MCP server that you've already created. It also is going to pull into like whatever cluster or infrastructure it's running on, right? So as I said, if you're running on Kubernetes, that's great. But if you also have VMs, cloud services that you're dependent on, just like basic things like bash commands can also be run as tools for the agent. We are using a Chainlit UI, which is custom, but there are a ton of other interfaces here for Slack, for Teams, for just having a TUI or a CLI interface that you want to interact with. It also has a LLM provider and model swappability, so you can kind of bring your own. We're just using OpenAI, but really it supports any light LLM, which is the LLM client provider, and you can bring your own model from this perspective and then rerun it and kind of decide what works best for your organization. And then the other thing that's cool is there's what's called custom runbooks. So these are actually just like agent skills, like skills.md files that you are putting and giving Helms access to. So say if you have a common issue with one of your services, or you have like an RCA that you've done from previous incidents that you've had, this would be a really good place to like place these on as agent skills. And these are reusable, right? Like it's just like a cloud skill. If you ever use those, it's an MD file, you can toss them in, and then Helms will pick those up and actually prioritize looking at those as well. So it'll ensure that if there is one for, in this case, I have the auth-service or the API, gateway, it will pull those in and run through the entire list of steps before, like, again, giving this output. So that's kind of what the agent itself is doing from an infrastructure perspective. And as I said, this is all running on Diagrid Catalyst for the agent reliability. So it's using state checkpointing, it survives restarts, and you can also replay it from the console as well. So all of these white, you can kind of think of as the pluggable components. And then if the dark green is more of the, Helms and then Catalyst and kind of what we're providing from a perspective. What else? Oh yeah, and then there are the workflow. So there is, of course, the workflow state store in order to get that durability. So we have a agent registry, the local agent memory for each run, and then also the agent workflow state store. That is also something that is provided by the Catalyst platform. So you have like a managed agent infrastructure layer that you can just run your agents on and kind of bring them and make them production ready. Cool. So I'm going to flip over now back to Helms again. So that's kind of giving you a bit of a zoom out of like what that agent architecture is. Now, if we want to run, here we go, actually. Now, if we want to take a deeper look into like what is actually happening in that cluster, if you remember, I was taking a peek and I was investigating it was the auth-service, so that one's still firing. So, it told me the last time I checked that it wanted me to upgrade those or update those limits. So I just wanted to show you that that was in fact actually the case. So if I jump over now into Kubernetes, hopefully this is big enough, but I can also see that I have my production namespace. I can also see that I have, a few applications here that are failing. And this is really just to give you these sample apps to show you what Helms is capable of with Catalyst. So I have that auth-service, which is in fact in CrashLoopBackOff. I'm sure, right, if I get that, yeah. If I kind of take a peek at that YAML, but it's like, I can type. So I can look at the last state and I can see, okay, yeah, this one, it was in fact out of memory killed. That's what Helms kind of gave me as the output to my last result. That's really handy. The other thing I can do is if I want to take a peek into what else is going on here. So this is I want to take a look into the checkout API. That's the other one I want to look at. So I can just say like, pretty generic. I can be extremely vague from Helm's perspective. It will look at all of the different Kubernetes pods that have this specific, tag label as well as name for it. And then again, it's going to get into each of these skills. So this first one is going to look for any skills that are my custom runbooks. Then it's going to look into, I think the better one is actually this one's the Kubernetes like queries. So it's going to run like get pods, get log. It's going to look at all that stuff for me. It can also do things like Argo, and it's going to provide me this full kind of end-to-end, output. And while this is actually running, I wanted to show you what this looks like in Catalyst. So I'm flipping over now to the Catalyst UI. I'm going to go straight into workflows just because I know that this one's running. So as I said, right, the biggest benefit that you get from this perspective of bringing your Helms agent to Catalyst is you'll see this running on and being wrapped in a workflow. So that was just running, actually already executed. So I will not be able to see it running right now, but if I kind of take a peek in here, I can look at all of the different inputs and outputs of each of these LLM calls and tool calls as well. So that's super handy. If you've ever done a lot of any sort of autonomous agent work, you'll know that like maybe on the first turn, it's like really easy to know what it calls the agent or it calls the LLM with. But after a few turns of that agent, very hard to tell exactly what's going on within your agent. Super hard to debug as well. So from this perspective, I can see like all of the different inputs and outputs to all of the agent turn like activities in this case. So you can see it's calling the LLM, it's calling a tool. Believe the first one, was fetching those skills. So it's gonna pull, all the skills from my database, and it also will showcase any errors it has or it like that get raised along the thing. So you'll see like a big red error if any of those happen, and then it's gonna kind of keep going. I'm going to, let's see. We should just show you one more. That is, let's just do one. I have a number of databases as well that were integrated. So one of them is Yugabyte, and you can see like also you get really good visibility into it as it's running. So, it's currently in process. That was a quick one, but you could see it kind of running there, and you'll see the updated status kind of as it's going on with the cluster. Similarly, one thing that is interesting is I jump into like a past execution here, you can see the parallelization on tool calls. So for instance, there's a number of these tools that are being called by Helms, as I said, Yugabyte, MCP, Pulsar MCP, like Kubernetes MCP, things like that. And each of these tool calls can be parallelized by the agent itself. So for instance, it's calling the Kubernetes a Tabula query in this case, it's calling, looking at Prometheus, looking at the rules, and then the third one here is ArgoCD. So it's actually able to call those out, fan out pattern, and then fan back in to kind of call the LLM and summarize the results of those tools. And then, I guess the other thing that I could call out here is you'll also see, of course, all of the different outputs. So this is the output from my previous run where it was looking into the auth-service CrashLoopBackOff. It's going to show that entire thing to me, which is the same thing that's output on my user interface. And this all shows up really nicely. So it shows up with an execution time, 30 seconds. It shows you the start and end time. You can do things like look through my prior executions. I can see it from a top-down level. So this is it's being called the Dapr HolmesGPT SRE Investigator workflow. This view is a little bit wild, but this shows like all of the different execution paths that it can take. So in this case, for an agentic workflow, oftentimes it'll choose its own path, but make up its own path depending on the order of the tool calls and depending on the number of activities it has or tools it has access to at that time. But I can see kind of the common path in some of these. And then I can also view kind of the breakdown. Let's see if I change this to 6 hours. I can see the breakdown. So, there was I ran 25 successfully. There were 2 that were terminated. And I can look at common themes across them. Like it takes around 2 minutes or it takes around 30 seconds. Or maybe you want to see, the ones that are taking a little bit longer. Okay, that one was nearly 3 minutes. Let's take a look into that. Let's see why, did it call the LLM 100 times or whatever. Kind of anomaly detection from that perspective. So that is kind of the workflow view. And the other thing that we can kind of showcase is each of these applications within that I'm running in Catalyst have an inherent identity built into them. So I have what's called an application identity. You can see this is listed as an app here. It has a number of things you can add on top of that. So the fact that it has an identity gives you the ability to add a access policy, meaning that like only certain other applications can access or call it. It can also, showing me all of those workflows that are associated to that app identity. But it also has an identity for the MCP servers. So this is super important, right? So I have 3 MCP servers in this case. These are my tools that Holmes is using to help me debug. I have one for GitHub. I have one for, this is the stream native MCP, and then I have the Yugabyte database. What we're doing here is we are taking a peek at the Gibbons MCP, and we have added on top an additional layer, which is the authorization headers on top of what we already have in the cluster. So we're hosting Yugabyte in cluster, and then we have added an additional authentication layer on top of that to be able to do just like basic header bearer token authentication on top of calling each MCP tool call. And you can see here as well, I have a access policy that is being applied. So these access policies will allow, in this case, the Holmes Investigator app to actually call this Yugabyte MCP, whereas like if I want to deny all access, you can absolutely do that as well. And yeah, I guess the other important thing is, so each of these, so I go back to MCPs for a sec, I have 3 of these. These are all going to be given their own inherent identity from Catalyst as well. So you'll see that I was just on that Yugabyte one. It also has an identity living within Catalyst as well. And that is going to be, give it the ability to have this authentication and authorization method with an entirely like passwordless way where it can both talk to, where Holmes can talk to it, and it can allow other resources, other agents to be talking to the database itself. So that's kind of what's going on from a Catalyst perspective. The other thing that I wanted to call out is we have a number of these components. So this is really our infrastructure layer that is providing the basis for which the agent platform is running on. And so you can see I have the memory, I have the registry, the runtime, and the workflow. These are all super core pieces of what we're providing as the infrastructure perspective. And so this agent workflow piece is really that kind of append only log where we are going to be adding each additional checkpoint into as those workflows progress along, and ensuring that during replay it has every single piece it needs to pick up from where it left off, where it leaves off if things go wrong. So this is kind of the managed infrastructure that we're providing. There's a ton of stuff in here. I'm not going to go through all of this, but you can see that all of these are being updated as we're kind of running through those workflows. And then, just from another observability perspective, let's see, I'll run this one more time just to kind of show you guys. Let's do, what was the other one? So we did this one, let's do API Gateway. Yeah. So I'm like, help me look into the API Gateway service. The other thing that Holmes can do from this perspective, you can replay a specific skill call just from the UI here. So I can just replay the, fetching one of these skills, which is looking into, the API Gateway service. I can specify, I just want to look at 11, which is the ArgoCD skill. So that's also a cool feature of just that comes out of the box with Holmes. But yeah, so while this is running, right, I'm going to see that workflow running within Catalyst. It's great. And it already completes. It completes so quickly. But as far as that goes, I can also view any of the metrics or API logs that are coming in to the platform. So this kind of gives you some ability into seeing like what's being called from where, and also like how frequently these calls are failing, right? So I can like look into, from an API perspective, I can look into the Holmes, I can see it's what MCP server I'm actually calling, things like that. And it's going to actually showcase me, the actual calls into those, and as well as showcase the trace IDs, the timestamp, anything else like that that is relevant. And then last but kind of not least, from a workflow perspective, we also can see a number of these metrics. So, I've made a ton of different requests over the past few minutes here just while giving this demo. I can see, that Holmes one is really, there's no errors. I can view kind of that gRPC error rate over time. This is reaching out to our Catalyst platform every single time for that workflow, for the workflow wrapper. And then I can also view this from a per app basis. So if I want to, dig a little bit deeper and see, okay, it's calling into the state API, it's like looking over that. This would be like the integration with the backend. So the integration with that workflow state. And then if there's any errors or, a bigger latency, this also gives me a view into that. So that's kind of the main benefits from that Catalyst perspective. This sample is all entirely available on GitHub, and I'll post the link in the chat here in just a little bit. But what we can do is I'm going to pass it over now to Martez, who's going to go through a little bit of what this code kind of looks like and just give you a quick run through of what we actually did by wrapping HolmesGPT with Catalyst.
Perfect. Thank you there, Alice.
I think I just have to stop sharing, and then if you just want to start sharing, then we're good to go.
Okay. We are up and running. Okay, so really quick, this is the actual Holmes deployment. So what we did, we were able to wrap the Holmes SDK in what we call a Dapr workflow Holmes runner. And then what that is doing is that's creating all of those different durability pieces that Alice previously showed you. So when we go into that UI and we're able to see the different workflows and we're able to see the different steps of the investigation, that's all made possible by wrapping the Holmes GPT SDK in this Dapr workflow Holmes runner. Now, one of the interesting things is we do this across several different tool sets. So you can do this for LangChain, you could do this for strands, but right now we see this for Holmes GPT. And so it's really straightforward. We just initially import a couple of different tool sets. So right here, we see we are importing that Dapr workflow Holmes runner. And then in here, we instantiate that runner with a couple different configuration options. And then we have all that rich functionality that we get with HolmesGPT. But then on top of that, we get that durability and that resilience that we enable from Diagrid Catalyst. So pretty straightforward. Now, one thing that I wanted to jump into is the skills, right? So Alice showed you a number of tool calls in that chainlet UI. And those tool calls are the capabilities that are exposed to HolmesGPT, the different things that HolmesGPT can call. But the skills ultimately define exactly how those tools should be called, right? So we have this grouping of what is actually available to the HolmesGPT executable. But as we learn more about our system, as we potentially get failures, we can feed data back into these different skill sets. And then now we have this grouping of runbooks to actually, make our investigations much smarter. So the very first one we'll take a look at is that checkout API. So just a few moments ago, and actually let me preview this markdown so we can see it actually in its raw form. Or sorry, not in its raw form, in its rendered form. So ultimately, we have a goal. So we want to establish like what we want to accomplish in this runbook. We can set some details about our environment, specific to our environment. And then we want to actually talk about the workflow and exactly which steps to potentially run, which tools to call, right? So by just defining these different skill sets, we can add functionality to HolmesGPT to declaratively state exactly what type of workflow and how we want to execute a specific action when we potentially discover an error that we've seen before, right? So that's a little bit about the skills. And that's a little bit about the tool set. A couple more interesting things with HolmesGPT. I think when so we want to make this productionalized, right? And so there are a couple different features. So number one, from a security perspective, HolmesGPT is going to initially query at the source, right? So Alice showed you a couple things. We have a Yugabyte deployment. We also have a Pulsar deployment. So let me pull this up here in our make file. So if we drill into here, we can see some of these different settings here. And so in these settings, one of the really interesting things that we see is we're not, overburdening our LLM agent with all these different tool calls and aggregating all this data at the LLM level. So HolmesGPT allows us to actually aggregate data at the source of the tool and then limit exactly what gets exposed to the LLM itself. So that's going to help from a cost perspective. And then as we're kind of running that agentic loop, is going to allow us to really narrow in on exactly what data we're calling and exactly what is the next tool step to call along the way. So it's really feature rich in that regard, very thoughtful implementation around making sure that we aren't actually hammering our LLM, and we're actually being really thoughtful about how we're querying data sets and bringing that data over to HolmesGPT for it to actually get us to the right result at the right time. So really quick, I want to share one last slide here. So this is available, as Alice said, in GitHub. And in addition to being available in GitHub, we have Catalyst Cloud, so you can try this for free today. We'll get you a link, but right now it's hosted at catalyst.diagrid.io. This is available right now. We can actually take our deployment of HolmesGPT, deploy that to Catalyst. We'll get visibility into those workflows. We'll see the AI agents, and we'll potentially see those MCP servers that you all have access to. So I will pass it back to Alice.
Awesome, thanks for that. You can just keep that slide up. It's all good.
Perfect.
Yeah, we just wanted to pause now to see if there were any questions. I saw that Ravi asked one in the chat a little bit earlier, just to clarify, right? So yeah, Ravi, you're right. If Kubernetes or internet connection is down, there's no HolmesGPT diagnosis from the operator. In this case, yeah, we are running on the internet where we are using what's called Catalyst Cloud, and this is our cloud hosted service. Now, absolutely, you can totally run this on premises. Catalyst is a on-prem hosted service, but you can also try that out for a free trial, or entirely host this in an air-gapped mode. And also, yeah, you just have to ensure that all of your dependencies, of course, are running on-prem or alongside your cluster, whether that is your LLM or infrastructure or whatever else. This can totally be run offline. Just the example that we're using today is internet required. So yeah, good question. I saw that there was any other questions. I posted the link in the chat as well, just like the code. So take a peek at that. It's super easy to get started, super easy to get set up. And then yeah, Martez, to your point, that replay functionality is being driven from the Catalyst UI as well. Yeah, for sure, Ravi, no worries. So essentially every single call that you saw that was the ritual call in there could be replayed just directly from the UI. I wanted to kick that off. Awesome. Well, I think that was mostly our content for today. If there's any other questions, feel free to post them in the chat and we can answer them live. Otherwise than that, we will shoot over a follow-up where you can reach out to us as well. And thanks so much for coming. Thanks for joining us.